Picture a tiny spacecraft, Voyager 1, racing through the infinite blackness, its silver body dwarfed by the endless void, solar wind whispering past its golden dish. Farther from home than anything we've ever built, Voyager 1 is now over 14 billion miles from Earth, so distant that the sun itself is just a pale point of light. It launched in 1977, riding a pillar of fire into the night sky, a message in a bottle cast into the cosmic sea, carrying humanity's dreams beyond the cradle of Earth. Its original mission, to perform close flybys of Jupiter and Saturn, capturing breathtaking images of swirling storms, volcanic moons, and Saturn's icy rings. But Voyager kept going, its plutonium-powered heart beating steadily as it ventured into the unknown, past the orbits of Uranus and Neptune, and out toward the edge of the solar system. This little probe is our eyes and ears in the vast dark, its instruments still listening for whispers of cosmic rays, magnetic fields, and charged particles. It carries a golden record, Earth's greeting to the universe, etched with music, images, and messages in 55 languages, a time capsule for any distant intelligence that might one day find it. Voyager 1 is more than a machine, it's a symbol of our hope and ingenuity, a testament to human curiosity and the urge to explore. Now it travels through a realm where the sun is just another star, its warmth and light barely a memory, as Voyager drifts billions of miles from home. Its faint signals, weaker than a refrigerator bulb, take nearly 22 hours to reach us, traveling at the speed of light across the cold emptiness. These signals tell stories from the edge of our solar system, where the solar wind collides with the interstellar medium in a turbulent, invisible frontier called the heliopause. Every day, Voyager 1 travels another million miles, propelled by its last gravitational slingshot, pushing deeper into interstellar space where no human-made object has ever gone. It's a pioneer, venturing into a place filled with the remnants of ancient supernova, clouds of dust and gas that are the ashes of long-dead stars. Here, the seeds of new worlds drift in the darkness, waiting for gravity to gather them into new suns and planets. No one knew what Voyager would find out there, whether it would encounter strange new phenomena or simply fade into silence. We were flying blind, guided only by calculations, courage, and the hope that our technology would endure the harshness of deep space. Then Voyager 1 made a discovery so strange, an abrupt spike in cosmic ray particles and a sudden drop in solar wind, that it would forever change our understanding of the universe. It was heading straight for a wall of fire, the boundary where our sun's influence ends and true interstellar space begins. The journey was about to get even more extraordinary, as Voyager 1 crossed into the great unknown, carrying our story into the stars. As Voyager 1 approached the very edge of our solar system, a region few had ever imagined visiting, it began transmitting streams of data that left scientists both thrilled and baffled. Voyager 1 was crossing the heliopause, the invisible boundary where the sun's solar wind is finally overpowered by the interstellar medium. Instead of a smooth passage, Voyager's sensors detected a region of superheated plasma, reaching an astonishing 50,000 degrees Celsius. This invisible wall of fire was a complete shock, a turbulent frontier no one expected, where the solar wind slammed into the galactic environment. The sun's protective bubble, or heliosphere, was colliding with the galaxy's own charged particles, creating a fiery moat around our solar system. This wasn't fire as we know it, but a searing plasma, atoms stripped of their electrons, compressed and heated by cosmic forces at the boundary. Voyager 1's suite of instruments, including its plasma wave subsystem and cosmic ray subsystem, measured the density, temperature, and energy of these particles, revealing a dynamic energetic boundary, far more complex than a simple line in space. The universe had surprised us again, and Voyager 1 had uncovered one of its biggest secrets, evidence of a turbulent, ever-changing frontier at the edge of our solar system. But a new question emerged. How could a 1970s spacecraft survive flying through a 50,000-degree wall of fire? And what did this mean for our understanding of the cosmos? The answer lay in the strange physics of deep space, and in the remarkable design of Voyager's scientific instruments. How did Voyager 1 survive the wall of fire, where temperatures soared to over 1 million degrees Celsius? The secret lies in understanding the difference between temperature and heat. In the interstellar plasma, the temperature is extreme, but the density is so low, just a few particles per cubic centimeter, that it's almost a perfect vacuum. These rare, high-speed particles barely collide with Voyager's hull, transferring almost no heat to its systems. It's like putting your hand in a 500-degree oven, The air is scorching, but because it's so thin, you don't get burned right away. Voyager's thermal insulation and gold-plated blankets protected its electronics, while its radiators released any absorbed heat into space. The wall of fire was real, but thanks to careful engineering, it posed no threat to the probe's sensitive instruments. Voyager's survival was a triumph of physics and engineering, its systems designed to withstand both the cold of deep space and the fleeting heat of plasma. But its next challenge would come from within. Years passed, and Voyager 1 pressed on, but time was catching up. Its primary thrusters, responsible for firing tiny pulses to keep the high-gain antenna precisely pointed at Earth, began to degrade after decades of exposure to the harsh environment of deep space. If Voyager lost its orientation even by a fraction of a degree, its weak radio signal would miss Earth entirely, and we'd lose contact forever. NASA's engineers faced a daunting task. How do you repair a spacecraft over 13 billion miles away with no possibility of a physical intervention? They scoured decades-old technical documents and original schematics, searching for any overlooked options in the spacecraft's design. Their hope rested on a set of backup thrusters, the Trajectory Correction Maneuver or TCM thrusters, unused since 1980, originally designed for major course changes during planetary flybys. These TCM thrusters were built for long, continuous burns, not the short, precise pulses needed for attitude control. Repurposing them would require rewriting software commands and recalibrating timing sequences from billions of miles away. No one knew if the TCM thrusters' fuel valves or heaters would still function after nearly 4 decades of dormancy in the freezing vacuum of space. But with no other options, the team meticulously crafted a new command sequence, tested it in simulators and decided to try. It was Voyager 1's last hope, a high-stakes gamble with humanity's farthest spacecraft. The fate of humanity's most distant emissary hung in the balance, as engineers waited for a signal that would take over 19 hours to reach Earth. The engineers faced a daunting challenge: how to communicate with a spacecraft billions of miles away, using technology from the 1970s. They gathered in mission control, poring over blueprints and data, determined to find a solution. Repurposing the old TCM thrusters, tiny engines unused for decades, they crafted new commands to coax them back to life for precise maneuvers. Using NASA's Deep Space Network, they sent the instructions across the void, a signal that would take nearly 40 hours for a round trip. The wait was agonizing. The team watched their monitors, hearts pounding as they awaited Voyager's response. Finally, the data arrived. The thrusters had fired perfectly, gently steering Voyager back on course. Cheers erupted in mission control. It was a stunning achievement. Remote surgery on a spacecraft billions of miles away, using tools and technology untouched for decades. This fix extended Voyager's life by years, allowing it to keep sending precious data from interstellar space. The team's response was one of pride and awe. They had not only solved a technical puzzle, but also pushed the limits of human ingenuity. More than a technical victory, it was a story of creativity, perseverance, and teamwork. The engineers had saved not just a machine, but a living legend. Voyager's journey would continue, thanks to the brilliance and determination of the team, and the cosmos still had more to reveal. The stories of the Wall of Fire, the daring journey through interstellar space, and the remarkable thruster revival capture what makes Voyager 1 extraordinary. It's a machine of discovery, revealing the universe's surprises, challenging our understanding, and expanding the very boundaries of science. Voyager 1's data has transformed our knowledge of the solar system's edge, unveiling the true nature of interstellar space and the heliosphere. But it's also a testament to human resilience, engineers reaching back in time to keep a distant probe alive, using ingenuity to solve problems decades after launch. Voyager 1 is more than a spacecraft. It's a living experiment, still sending signals across billions of miles, continuing its mission to explore the unknown. It's a symbol of our curiosity, our drive to overcome the impossible, and our relentless pursuit of knowledge. Voyager 1 carries our music, our greetings, and our story, an interstellar message in a bottle, reaching out to the cosmos. Its journey inspires scientists, engineers, and dreamers, reminding us that our reach can extend far beyond our home planet. Its mission continues, outlasting us all, a silent traveler, gathering data from the edge of the unknown. Voyager 1 will drift between the stars for thousands of years, a relic of human ambition and scientific achievement. Its legacy is not just in the data it sent, mapping magnetic fields, cosmic rays, and the boundaries of our solar system, but in the inspiration it provides to generations of explorers, scientists, and all who look up at the night sky and wonder. It's a whisper in the cosmic wind, a reminder that we dared to dream, to build, and to reach for the stars. Voyager 1's ongoing mission is a beacon for humanity, showing what's possible when we unite in the pursuit of discovery. And so Voyager sails on forever into the unknown, carrying our hopes, our science, and our legacy into the stars. Voyager 1's Odyssey is not just a tale of the past, it's a spark lighting the way for the future of deep space exploration. As its signal grows ever fainter, new missions are being dreamed up in laboratories and classrooms around the world, inspired by Voyager's daring journey. Scientists are now designing probes to visit distant ice giants, robotic explorers to map the hidden oceans of Jupiter's moons, and even interstellar craft that could one day catch up to Voyager itself. Emerging technologies like solar sails, miniaturized spacecraft, and artificial intelligence promise to push our reach farther than ever before. Projects such as Breakthrough Starshot imagine tiny probes racing to neighboring star systems, while next-generation telescopes will peer deeper into the cosmos, searching for new worlds and signs of life. Yet, the heart of these missions remains unchanged: the human urge to explore, to ask questions, and to seek answers in the vastness beyond. Voyager 1 reminds us that every new journey starts with a bold idea and the courage to launch it into the unknown. As we chart new frontiers, we carry with us the lessons and the spirit of Voyager, never ceasing to wonder, never hesitating to reach. The universe is waiting, and with each new mission, we take another step into the cosmic ocean, guided by the legacy of those who dared to go first. As Voyager 1 drifts ever farther from home, it carries with it more than instruments and data. It holds a mirror to our own existence. For the first time, humanity gazed back at itself from the edge of the solar system, a pale blue dot suspended in a sunbeam. That single image captured by Voyager reminds us of our shared fragility and unity on this tiny planet. Voyager's journey is more than a feat of engineering, it's a testament to our collective curiosity and the bonds that tie us together as a species. Out there in the silence between the stars, Voyager whispers our story, a story of wonder, of hope, of reaching beyond the horizon. Its golden record, etched with music, greetings, and the sounds of Earth, is a message to the cosmos and to ourselves. We are here, we are learning, and we are yearning to understand. In a universe vast beyond measure, Voyager reminds us that our greatest strength lies not in what divides us, but in our shared quest to explore, to dream, and to connect with the unknown. As we look to the stars, we are reminded that every journey outward is also a journey inward, inviting us to reflect on what it means to be human in an infinite universe. Voyager's silent passage is a gentle call to cherish our home, to care for one another, and to never stop searching for our place among the stars.